BSc Chemistry, Organic Chemistry, SEC second. Topic Fuel Chemistry, presented by B. Madhav Narayan. Petrochemistry is one of the parts of fuel chemistry. Here you study cracking up petroleum in continuation of the previous session. The contents of this today's session are aim of catalytic cracking, mechanism of catalytic cracking, advantages of catalytic cracking, fixed bed catalytic cracking, moving bed catalytic cracking. Now let us first study what is catalytic cracking. Catalytic cracking, including fluidic catalyst cracking, are processes in which a chemical catalyst is used to increase the yield of thermal cracking process. Acidic catalysts like aluminum silicate or zeolite catalyst added to the feedstock stream allows the breakdown of long chain molecules into lighter short chain hydrocarbon molecules at a temperature 460 to 520 degree centigrade and a slight pressure of 1 atmospheric. The aim of catalytic cracking is to increase gasoline by converting heavy fuel into fuel oil into gasoline. Second one, to produce better quality of gasoline and octane number of gasoline. Number 3, to produce some important chemicals like propane, butane and hydrocarbon gases. Now what is the mechanism reactions of catalytic cracking? The feedstock of heavy fuel and fuel oil contain high complicated mixture of chemicals. Hence, it is difficult to study the path of chemical reactions. In describing the main reactions which is led to decrease in the molecular weight for feedstock, the mechanism of catalytic cracking involve primary reactions and secondary reactions. In primary reactions, there is formation of carbonium ion as an intermediate. In the secondary reactions, rearrangement occur along with dehydrogenation, producing aromatic compounds from hydrocarbon chains. Example, an alkene which formed from thermal cracking, then protonation of alkene by a catalytic to form carbonium ion. CnH2n plus 2, general formula of alkane, on thermal cracking gives CnH2n, H plus gives CnH2n plus 1 in presence of H plus. Now what are the advantages of catalytic cracking? Here a suitable catalyst like zeolite, aluminum silicate Al2SiO3 thrice or alumina Al2O3 is used. Now question generally asked in the examination that catalytic cracking is better than thermal cracking because the yield of petrol is higher, the quality of petrol is better, the low pressure is sufficient, the controlled cracking to get desired petrol, and the product contains higher amount of aromatics, therefore it has better anti-knock properties. There are two methods of catalytic cracking. One is fixed bed catalytic cracking, second one moving bed catalytic cracking. This is the schematic view of fixed bed catalytic cracking. The various chambers are preheater, catalytic chamber, fractionating column, then at last stabilizer. I will discuss now the working of fixed bed catalytic cracking. The oil vapors are heated in a preheater to cracking temperature 420 to 450 degrees centigrade and then forced through a catalytic chamber containing artificial clay mixed with zirconium oxide. It is maintained at 425 to 450 degrees centigrade and 1.5 kg per square centimeter pressure. During their passage through the tower, about 40% of the charge is found to be converted into gasoline and about 2 to 4% of carbon is formed. The latter gets absorbed on the catalyst bed. The vapors produced are then passed through fractionating column where heavy oil fractions condense. The vapors are then led through a cooler where some of the gases are condensed along with gasoline and uncondensed gases move on. The gasoline containing some dissolved gases is then sent to a stabilizer where the dissolved gases are removed and pure gasoline is obtained. Second one is moving bed catalytic cracking. The working of moving bed catalytic cracking involve the solid catalyst is very finely powdered so that it behaves almost as a fluid which can be circulated in gas stream. The vapors of cracking stock, gas oil, heavy oil, etc. mixed with fluidized catalyst is forced into large reactor bed in which the cracking of the heavier into lighter molecules occurs. Near the top of the reactor, there is centrifugal separator called cyclone, which allows only the cracked oil vapors to pass on to the fractionating column, but retains all the catalyst powder in the reactor itself. The catalyst powder gradually becomes heavier due to coating with carbon and settles to the bottom, from where it is forced by an air blast to regenerate, maintained at 600 degree centigrade. In the regenerator, carbon is burnt and regenerated catalyst then flows through a standpipe for mixing with fresh batch of incoming cracking oil. At the top of the regenerator, there is separator which permits only gases like carbon dioxide to pass out but holds back the catalyst particles. This is how the moving bed catalytic cracking functions. At last, for more information, you can refer these books. Number 1, P.C. Jain, Engineering Chemistry, Dhanpat Rai and Sons, New Delhi. You can also refer sanfoundry.com or research.net, next twitter.com. Thank you.